Okay, so now we're going to talk about absolute value inequalities, and it's going to have a less than symbol. So the way I do these problems is very specific. So let's say, for example, we have the absolute value of x is less than 3. So, you think about the number line here. Here's 0, here's 1, 2, 3. And let's say less than or equal to. Let's go ahead and put the equal to in. So you're saying, okay, I can include 3, and then I can include numbers like 2 and 1, and all the numbers in between. All of those are less than 3, right? So I'm just going off this way. And so you might be thinking, oh, x is less than 3, right? That's true. You take the absolute value, and you think of the numbers that are less than 3. And that's going to work just great for a while. Okay, now let's see what happens when we get to 0. Is 0 less than 3? Yeah, 0 is less than 3. The absolute value of 0 is less than 3. So we're doing absolute values here, right? Okay, and we go to -1. We'll skip all the decimals and fractions. Is the absolute value of -1 less than 3? Well, the absolute value of 1 is less than 3. Yeah, sure. -2, okay, that's fine. The absolute value of -2 is less than 3. Yeah, that works. What happens when I get to 3? Oh, we had equal to's. Dang it, I forgot to put the equal to in. Okay. So is the absolute value of -3 less than or equal to 3? The answer is yes. Okay, so we're all smiley faces, up to this point. 3 is less than or equal to 3. It's equal to, but yeah, we get to include that. Now, what if we keep going? What if I go to -4? Is the absolute value of -4 less than or equal to 3? No, that doesn't work. We've gone too far, okay? So where do we have to stop? We have to stop at -3, okay? So if you go any further, then when you take the absolute value, it's going to be bigger than 3. And so you can't get too small, okay? So sometimes maybe that's hard to think of when you're thinking about the less than. You're like, oh, all those numbers are going to be less than 3. But if it gets too small, then you take the absolute value, it's going to be bigger. Okay. So how I solve these is I make what's called, what I like to call, a less than sandwich. So you're going to take whatever is in the absolute value. By the way, isolate the absolute value. You're going to take whatever's in the absolute value, and you're going to sandwich it between the positive case and the negative case. Okay? So if I have something like the absolute value of x plus 7 is less than 22, then I take the absolute value part, x plus 7, and I make, that's the meat of the sandwich, and then I sandwich it between the positive case and the negative case. The negative case will have to be on the left because it's smaller, okay? So I call that a less than sandwich. We're using less than symbols. Okay. That's my explanation. That's how I do it. Where's my example? Sorry about that. I had to go get the example. Okay, there it is. All right, so we just take the absolute value part. It's already isolated, so you have absolute value. Note that it's a less than symbol. Okay. Oh, and it happens to be a 3 over here. Okay, so take the x minus 4, take it out of the absolute value, sandwich it between 3 and -3. And then now it's a compact compound inequality. We worked on these in the last video. We just want to solve for x, add 4, right, to each of the sections. And so I get 1 is less than x is less than 7. They want me to graph it, so I can do that by making a number line. Here's 0, 1, 2, 3, 4, 5, 6, 7. And it's going to be between those numbers. Now, I don't have the equal to part, so I have to have parentheses. And then it's all those numbers in between. Those are the ones that will work. How do I write the interval notation? Parenthesis 1, comma 7, parenthesis. And in set builder notation, it's a set of x such that 1 is less than x is less than 7. Okay, but I like the interval notation. And here's the graph. Okay, we'll do something different for greater than.